Hey, welcome to Argonaut Cycles. My name is Ben Farver. I'm the owner here, and we make custom carbon fiber road bikes, soup to nuts, here in our facility in Bend. So I started the company about 12 years ago in Portland and moved to Bend in 2015, primarily for lifestyle reasons. I had a little boy, and I grew up in the mountains of Colorado, and I wanted him to grow up in the mountains, but also close to his grandparents, so Bend kind of made the most sense. So I think one of the cool things that we do here at our shop is that we make every part of this bike. So we make the frame, the individual frame components, which I can kind of show you over here. We make all the tooling for the frame components. We start with raw material that we store in our freezer. We lay up the individual parts from scratch and then end up with the complete finished bike. So in this facility that's up here next to Summit High School, off Lolo Drive, is our customer-facing showroom, which is where we are right now. And in the back, I'll show you here in a second, is our CNC machine where we make the tooling, and then the layup area where we actually make the frame parts. And then we have another facility that's down off Century Drive, and that's where we actually build the frames, bond the pieces together, and do the final finish. And before finally shipping complete bikes out the door, we take the frames back up here to assemble with all the components and then box them up and ship them out. So I'd say a really low percentage of the bikes that we make end up staying here in Oregon. The vast majority are shipped throughout the United States, and about 20 to 25% are shipped internationally. So we are a direct-to-consumer company. So we have a distributor in Europe that we work with, but inside the United States we sell directly to individuals, so not through shops. And we find that that's really the best way to give our customers the best experience, the most attention, and the best final finished product, which is the bike. So why don't we go in the back? I can show you the CNC area and the tooling, and then we've got some guys actually laying out parts as well. This is our Haas Vm3 Cnc Machine. It's a 3-axis CNC machine, and what we do here is make the frame tooling that molds our individual carbon pieces. So our carbon fiber components are molded in an aluminum cavity, some actually steel cavities, some aluminum cavities, and the CNC machine is the what we use to actually remove the material from the inside of the aluminum block. So we are very proud of the fact that we're a nearly entirely vertically integrated company where we control every aspect of the bicycle, including the tooling and the individual pieces that make the frame. So this is really square one in terms of making a frame. So we, Argonaut road bikes, the new model, the RM3 is what it's called, ranges in price from $6,000 for a frame set, up to $14,000 to $15,000 is our most typical complete bike. So we make those in both custom and pre-designed geometries. So for custom tooling, we're actually making unique one-off customer-specific molds for that frame. And then for pre-designed geometry, that customer gets a frame that is custom to them in terms of how the individual plies of carbon are engineered inside the frame, but we're using off-the-shelf tooling that's already been made for the specific size. So this is kind of square one where we machine the actual tooling. Right here we have one of our pre-designed geometries. This is the head tube part of the tool. So once this comes out of the CNC machine, it'll be polished to lend a nice glossy finish to the final part, treated with a mold release so that the part comes out, and then goes over to our production area where we make the individual frame components. So the first step in the making of the actual frame parts starts with the raw material. So we use what's called pre-impregnated carbon fiber. pre-impregnated means that they're individual strands of carbon, but they've been pre-saturated with the resin. So carbon fiber is a two-part material. You have one part fiber and then the second part resin. You can make carbon fiber parts in a number of ways, one of which is wet layup, which is you actually apply the resin to dry carbon fiber. What we use that we feel is a better use of the material, a better technology, is called pre-impregnated carbon. So we keep it in a freezer because the resin that saturates the carbon is heat activated, and by keeping it in the freezer you keep that resin from curing, and so it keeps for longer. So pre-impregnated carbon fiber can actually expire, but it keeps for longer from expiring when you store it at 0 degrees. So we start with our raw material, which is the pre-impregnated carbon fiber here. We take that out, and then it's rolled onto our automated plotting machine, which is this table right here. So this is a computer-operated machine with a blade on it that cuts out the specific plies of carbon so that then we can lay them up on a mandrel to make our part. So in any given carbon fiber structure, particularly ours, you have what's called the layup schedule and then the layup pattern. So the layup schedule is the orientation of the individual plies on top of each other and how the plies of carbon vary in terms of bias to each other. So that's your layup schedule. And then your layup pattern is the shapes that you cut out the individual plies of carbon so that they lay over the structure to yield and end up with your specific carbon fiber schedule. So schedule creates the flex characteristics of a part, and then the pattern achieves that schedule on a specific shape. So that's what these guys are doing over here. They are laying up steer tube and fork legs for our bike. So we are one of the only companies in the United States that makes our own forks. The vast majority of bicycle forks, carbon fiber forks, are made in Asia. But the design of the fork, the handling characteristics of the fork were both really important to get right specific to our bike, so we decided to take the manufacturing of this part in-house as well. So what these guys are doing is they're laying cut plies of carbon onto a silicone mandrel. So the mandrel holds the interior shape of the part, and also when you put it inside the tool or the mold, it heats, it expands when you heat the mold. So the expansion of the silicone rubber inside the mold fuses the individual plies together as the resin goes from a liquid to a solid state as it cures. And then once the curing process is finished, which takes about an hour and a half, and the mold cools, the silicone shrinks back down, and then you can pull it out of the finished part, and you get your final structure, your hard piece of carbon fiber. And so it's important for us to be as vertically integrated as possible, and one of the key ways we're able to do that is with the use of these 3D printers. Most carbon fiber bicycle components are made with a process called bladder molding, and that bladder uses a latex bladder as a mandrel, as a form to lay up on. That latex mandrel is really difficult to make in-house. Most companies source those latex bladders from a couple of companies in the United States, but in which case you're beholden to another supplier for a key part of your process. We figured out a technology that we actually have a patent pending for, which is a modified way of molding carbon fiber called trapped rubber. And so the rubber refers to the silicone rubber of the internal mandrel. And then the trapped rubber is that this is contained in a mold. But to make these specific forms, what we actually do is we 3D print a mold to make this part. So the 3D printing, the material is not It's not very expensive, and it's not active time. These 3 printers can run 24 hours a day to make our molds that make these layup mandrels. So I think it's a much improved process from both a part quality standpoint, and then also just the fact that we're not reliant on any other company for any part of our process. So this is a piece of raw pre-impregnated carbon fiber. This is the material that makes the entire bike. So in one frame, fork and stem all included, there are over 500 individual pieces of cut carbon fiber. And it weighs, a frame my size, painted, finished, weighs about 740 grams, which is a little less than 2 pounds, right around 2 pounds. And again, the fork and the stem together weigh 370, about 500 grams, so an additional 1.5 pounds in there. So complete bikes, including components and everything, typically range anywhere from a little under 15 pounds to just under 16 pounds. This fatigue test fixture is a really key part of our process because it allows us to innovate and iterate more quickly and still get the data that we need in terms of both a product durability standpoint and a safety standpoint. So this test lab that we're in right now, we built about 6 months ago, and like I said, it enables us to really keep tight quality control over all the products we make. So we have impact testing fixtures here, which are weighted. We actually drop heavy weights on different parts of the frame to ensure their durability. And then to this cycle fatigue test fixture, which actually comes out of Italy. And what this does is it replicates a lifetime of vigorous use of a bicycle frame. So we can chase out any layup deficiencies, any flex inadequacies, or potential warranty problems here in the lab before a customer ever sits on them. So it's beneficial from both obviously a safety standpoint, but also a quality control and a warranty standpoint. So we're here in our bonding room where we take our finished frame parts, cut them to the appropriate size of the geometry, and bond them together, actually with the same adhesive that holds a lot of airplanes together. So once the adhesive cures, take it out of the fixture, which holds all the frame parts in the correct position and alignment while the adhesive dries, cures. And from here we go out to our final finishing area, which is the paint department. So paint sells bikes. Cool paint jobs are really what draw customers' attention to our brand and also make an individual customer's bike special to them. So it's important to be able to control that part of the process as well. We're here in our spray booth where we use an automotive grade 2-stage paint, same paint actually that Mercedes uses to achieve really any kind of design or level of finish that a customer wants. We can focus on low weight, thin millage paint for lighter weight frames to multicolor, super vibrant custom reflections of the individual's lifestyle and tastes and whatever they want. So paint is the last part of our build process. We look at making sure that frames look good, one for sure, and then also are durable and have a finish that will last the lifetime of the frame. Which is actually a 10-year warranty. We offer a 10-year warranty in our frames, which is about the time frame that any well-made, high-performance, super lightweight race bike should last. This is a finished, ready-to-ship Argonaut frame set. So we make every piece that you see here, the frame, the fork, the stem. Actually, interestingly enough, Robert Axle Project is a local company here in town that makes our axles for our through axles. So we are gearing up to increase production. Right now we have capacity for a frame a week. And there are 80 man hours in each frame. And we're finishing up our R&D phase of the RM3, which is our latest frame, and now we're moving into scaling production. So we're adding a couple people this week. Over the next few weeks, we're going to probably be adding a couple more to try to ramp up production to get more numbers out the door. Thank you for taking the time to learn what makes Argonaut bicycles unique. To buy a bike, reach out to me directly through our website, which is contact@argonautcycles.com. We'd be happy to help you get fitted and sized up and one made just for you.